Hello, and welcome to the General Physics Laboratory. This week, we will study the kinematics of two systems where objects move along a line. Kinematics is the description of an object's motion through its position, velocity, and acceleration. The first system we will study consists of a cart that can roll along the table. A string is attached to the cart that extends over a pulley and is tied to a hanging mass. When the mass is released, the two-mass system will experience constant acceleration. Using the capstone software and the smart pulley, we can find the relative position, velocity, and acceleration of the cart. However, the smart pulley cannot measure the positions of the cart directly. Instead, it measures its own angular displacement. This angular displacement is tied to the motion of the objects if the string moves along the pulley without slipping. The cart's displacement is equal to the angular displacement multiplied by the radius of the pulley. Once this value is obtained, capstone calculates the velocity and acceleration. In this experiment, the cart is released from rest and allowed to accelerate for a short period of time. We use this data to investigate the relationships between the position, velocity, and acceleration of the cart. Later in the course, we will look closer at how the acceleration depends on the masses of the cart and hanging mass. The next system we look at is a metal sphere rolling down an inclined plane. At the bottom of the inclined plane, a photogate will measure the speed of the sphere as it passes. The photogate uses a laser sensor to measure the time it takes the ball to pass through the gate. One side of the gate contains a laser source, while the other side contains a detector. When the ball first blocks the beam, an internal timer begins. This timer stops once the laser again hits the detector when the ball has passed completely through. By providing capstone with the diameter of the ball, it calculates the speed by dividing the diameter of the ball by the time interval measured by the gate. In this part of the experiment, we release the metal sphere from different points along the inclined plane and record the final velocity measured by the photogate. We expect that the further the ball rolls down the track, the faster it will be traveling. To find out the exact functional dependence of velocity and distance, we will need to analyze our data in more detail.